Today's topic is all about names and formulas for acids and bases, and those are some specific types of compounds that we're going to get into later. But before we do that, we're going to do a little bit of a review of our ionic and our covalent compounds that we did before Thanksgiving break, because it's been a little while, so we need to kind of refresh and get back into the groove of practicing this stuff. Partially because it's been a while, but also partially because next week on Monday you guys are going to have your test over this unit. So we're finishing up the last new information today with the acids and bases, and then that's on Canvas. And then on Thursday, we're going to be reviewing and doing some practice with all the mixed names and formulas. Because then next week on Monday, you're going to take your unit test. And then the last few classes we'll work on kind of reviewing and doing some other stuff before the final exams. Okay. So we only have 15 days until Christmas break. So, it doesn't seem like a lot, but it'll go by really fast. So this is a flow chart. Okay. And I just made this is in Google Slides. If you actually Google, compound names or compound formulas flowchart, you will find like PDF files. Like I'll show you, like I'll just Google, because there's different ones. So naming, let's see, type, oh my gosh. Naming compounds flowchart. So if I just Google it for naming compounds, and there's like several different ones, okay? They all pretty much do the same thing. Some of them are just organized a little differently. But it all starts off with, does it have a metal or ammonium? Because that's going to tell us if it's an ionic or a covalent compound. Okay. There are some that are a little more complicated. I actually kind of like, I think this is the one. This is a good one because it has our ionic compounds. It has the ones with and without transition metals, has binary, and it also has acids, which is what we're going to do today. And then it also has these other elements on it as well. So there's a lot of different ones. So that's for naming. And then you could also just change this to writing formulas. And you'll get one that some of them might be similar. So you have to kind of look. So like here's one that says writing a chemical formula, because sometimes it'll still pull up the one for doing the names. But you can also use, like, here's one for how to write formulas. And so it walks you through how to do the formulas. So you can find different flowcharts online. The one that I'm showing you right now is I've kind of taken those and I've put it into a Google Slides activity practice assignment. So you start here, wherever this box that says start, which on this one, it's right up here. And the way you do this is it's going to have a question, and it's a yes or no question. So you either answer yes or no based on your formula. If you answer yes, you follow the arrow to the next box, and then it usually will have another question, and you'll keep answering yes or no until you get to where you have to do something. For example, let's say that we start here, and let's say we say yes to the first question, so that's ionic. And then let's say that we then end up saying yes to the second question. Then when we get to this box, now it's not a question, it's telling us to do something. And then after we do that, then we continue on, and there's another question. We answer yes or no, and then based on that, it's going to tell us to write or do something else, and that's going to be when we're finished. Okay, so you kind of follow it until you get to the end where it says you're done. And the way, got somebody else trying to come in. And so what we're going to do is we're going to take a look at this, and then we're going to look at some formulas. We're going to try to write their names, and I'm not going to tell you if it's ionic or covalent. It's going to be mixed, and you have to use this flow chart in order to kind of figure out how to do the name of the compound. Because now that we've covered all the ionic and the covalent, this is when people start having trouble because they start mixing them up. And, like we only use the prefixes on the covalent compounds. We only use Roman numerals if it's an ionic compound that has a transition metal. So this is where once we start putting together, people have trouble telling the compounds apart. So they don't use the correct rules to write the name or the formula. So this is kind of like a little guide to help you if you're still kind of struggling with that. So the way I would do is I would start up here. The first question is always, is there a metal or NH4 in the formula? Because if it has a metal, or if it has NH4, that's automatically going to be ionic, okay? Then the next question, if I say yes to that one, once I identify that it's ionic, then I need to look, is the metal, if it has a metal, is the metal tin, lead, or is it a transition metal? Because remember, these transition metals, the ones that are kind of here in this middle area where it's kind of outlined in red on this picture of the table, all of those transition metals and tin and lead, they need Roman numerals in the name. The only ones that don't are these three right here: silver, cadmium, and zinc. Okay. But all the other transition metals, they have multiple charges. And so I need to identify, is the metal one of those transition metals or tin or lead? Because if it is, if I say yes, then I have to write the name of the metal. And then after the name of the metal, I need to write a Roman numeral in parentheses to indicate the charge. If I say no, if it's just a regular metal, it's not tin, lead, or a transition metal, then I just write the name of the element from the periodic table. Or if it's ammonia, if it's NH4, then I give it that name ammonium, because that's that polyatomic ion from our list from before break. After I write that first part, then I follow the arrows. I go here. The second part is the anion. That's the negatively charged one. So I look at it. Is it a polyatomic ion? And I answer yes or no. So remember, polyatomics are the ones that are made up of more than one atom. Okay. So if the second part of the formula has more than one atom, that's a polyatomic ion. And that's where I would look at my list. So like on this one right here, I have this list next to it. Okay. And we have the other ones in our lesson from last time. Okay. So you can look on a list of polyatomic ions to figure out the name that you would need to write for it. Okay. If it is not a polyatomic ion, if you say no, then that means it's just a regular non-metal from the periodic table. And that means that you just need to write the name of the element, but you need to change the ending to IDE. And then once you've done all of that, then you're done. If we go back to the start, if we answer no to this first question, no, it does not have a metal and it does not have NH4 in the formula, that means that it's covalent, okay? And so then from there, then we look at, okay, does the first element have a subscript? If it does, then we need to look up the correct prefix to use to put in front of the name of that first element. If it does not, then there's no prefix, because if there's one of the first element, we don't use mono. So if we say no, the first element doesn't have a subscript, then we just write the name of the element from the periodic table. We don't need to add a prefix. And then after the first element's done, the second one's always the same. You look the name of the element up from the periodic table, you add a prefix based on the subscript, and you change the ending to IDE, and then you're done. So I'm going to go to this next one, and the next one, it's actually going to have a formula here. So oops. This one is CuNO3. So this is the formula. Okay, so we're going to start here with this first question. So you can either answer in the chat, or if you want to unmute and answer, you can do either one, but I do need to have some participation, okay? That way I know you guys are at least alive and hearing me. So the first question, is there a metal or NH4 in this formula? I think it's pretty obvious there's no NH4, okay? So is there a metal in the formula? And if you need to, I'm going to switch over. So it's CuNO3. I'm going to switch over so you can look at this periodic table to see if you need to check to see whether something is a metal or a non-metal. So the formula was Cu and then NO3. So is anything in that formula a metal, yes or no?
Yeah.
Yeah, so, okay, we got Layla said yes, and I think that was Gift also said yes. Which one is the metal? Because you're correct, there is a metal.
Cu.
Yeah, it's Cu. So Cu is copper, okay? So if there is a metal, that means we're gonna go this way, because that means yes, it is ionic, okay? Is that metal a transition metal? Okay, obviously we know it's not Sn or Pb, because you guys just said it's Cu, but is Cu a transition metal? So let me go back to our periodic table so y'all can see if you don't have one pulled up.
Yeah.
Yes, it is. Okay, it's Cu's right here, is in the middle area. That is a transition metal. So that means that it needs that's where I'm following this chart. So if I get there, if I say yes, that means that I have to write the name of the metal, and then I have to write a Roman numeral after it. Okay, so I know that it's gonna be copper, but I don't know what Roman numeral to put in here yet. Okay, so we'll come back to that. okay? Because the way we figure out the Roman numeral has to do with this negative ion. So let's do the second part, and then we'll come back and finish the Roman numeral. So the next part says, is the anion a polyatomic ion? So Cu, you guys said that was the metal, that's the cation. So that means the rest of the formula is NO3, that is the anion. So is NO3 a polyatomic ion, or is it just a non-metal from the periodic table? What do we think? So does NO3 have one element in it or more than one? This NO3 right here. Yeah, it's got more than one, right? It's got one nitrogen and it's got 3 oxygens. So altogether it's got 4 atoms. So remember, polyatomic means more than one. So NO3 is a polyatomic ion. It's not just a nonmetal from the periodic table. If it was just one nonmetal, it would just have one symbol. It wouldn't have an N and an O. So the N and the O3 tell me that it's a polyatomic ion. So that means I'm going to come over here and I'm going to look at a list. So you can look one up on the internet, or you can use the one that's on Canvas in the lesson. I'm going to zoom in just a little bit so that you guys can see this a little bit better. Okay, so I'm looking for NO3. So if I look through this list, NO3 is right here, NO3, and it has a -1 charge, and the name for that is nitrate. So it is a polyatomic ion, and the name of it is nitrate, okay? So it's gonna be copper something nitrate. So now we gotta go back and figure out this Roman numeral thing. Now that I know that the polyatomic ion is nitrate, what I need to do is I need to use its charge. This is where I have to work backwards. And so I have to look at the charge of my anion, my negative ion, and do a little bit of math and work backwards to try to figure out the charge on the positive ion. So NO3 right here on this list, it's just got a -1 charge, because up here it's just a minus. If it just has a minus, that's just a 1, okay? If it's more than 1, it'll have like this one, it'll has like a 2- or a 3-, okay? So nitrate is -1, okay? And if I look at the chemical formula, CuNO3, okay, it's not in parentheses. That means there's only one nitrate in that formula. If there was more than one nitrate, the NO3 would be in parentheses and there would be another subscript after it. So the fact that it's just NO3 tells me there's just one nitrate ion. So that means that there's only one of this -1 charge, okay, total. So that means that if that NO3 is -1, then the Cu, the copper side, it has to balance that out to equal 0. So if NO3 is -1, and there's just one of it in that formula, then in order to balance out and equal 0, what does the copper charge have to be? So NO3 is -1. So then what does the Cu have to be to equal it out and make it 0? Or to balance it out, I guess you could say. So if I have -1 and I want to get to 0, what do I need to add to it? Yeah, so Layla just said 1. So it's going to be a +1. So that means that here I need a Roman numeral 1. Okay. So if you are still struggling with what we just did with calculating the Roman numeral to figure out, or sorry, calculating the charge to figure out the Roman numeral, I would highly encourage you to go to that last page in the module for names and formulas for Unit 4. The last page, there are a bunch of tutorial videos from YouTube for doing all the different names and formulas, and scroll down to the one that mentions doing the names for ionic compounds with transition metals. And I would highly encourage you to watch those videos. I think there's an introduction one, and then there's one that has practice problems with transition metals, because he goes through several of these. And so you can kind of pause it and maybe watch one as an example, and then you can look through the other ones and see if you can practice getting them and checking yourself. because if you're struggling with this, then that's what you need to work on, is you need to work on figuring out how to do the Roman numerals for the name. Okay, so now that we have it all together, I'm going to put it all together now here in the last box. So the whole name is copper, not copier, copper 1 nitrate. Okay, so for the final answer, that would be the final name, copper 1 nitrate. All right, let's do the next one. Okay, next one is Li2O. So again, starting from the beginning, is there a metal or NH4 in the formula? I feel like, again, it's pretty obvious there's no NH4. So really, we just need to ask, is there a metal in the formula? Yes or no? Okay, Camila says yes, she is correct. Which element is the metal, the Li or the O? What do you guys think? It's Li. So if I come here to my periodic table, remember the zigzag line is right over here. It starts on the side of boron and it zigzags down. Everything to the left is a metal, and lithium is all the way over here. So it is a metal. So that means this is ionic, okay? So then the next question is it a transition metal? We know it's not tin or lead because it's Li, okay, which is lithium. So is lithium a transition metal? So if we look at our periodic table, is lithium in the transition metal groups? It is not. Thank you, Layla and Camila both. And so that means that it doesn't need a Roman numeral. So this is going to be easier than the last one we did because we're not going to have to do that weird calculation thing. So that means I'm going to say no here. And that means that if we look back at our instructions on the first one, we just write the name of the metal from the periodic table. That's it. No Roman numeral needed. So I'm going to write lithium here. Okay. Now, the next part for the second part of the name is the anion, a polyatomic ion. So looking at this formula, we did the lithium. So the second part is the O. Is that a polyatomic ion? Yes or no? See, can we get somebody other than Layla, Camila, or Gift, because they've been participating. The rest of us are kind of quiet. Let's see who else is in here. Gabriel, what do you think? The O, is that a polyatomic ion? Yes or no? How about Jennifer? Jennifer, are you there?
I still don't understand this. So.
Okay, so going back to from before the break, so this word polyatomic, poly, the prefix poly means many or more than one. So if something is a polyatomic ion, that means that it's going to be made up of more than one atom. So if I look at this formula, if I just have O, is that more than one atom?
No.
No, so that's not a polyatomic ion. If it's a polyatomic ion, it's going to look like these over here on this list in the blue right here, where see how they're all different elements? Like this one has got an O and an H. This one's got a Cl and an O. This one's got an N and 3 O's. So all of these on this list, they're made up of more than one atom. So when you get to that question where you need to know if it's a polyatomic ion, you look at the second part of the formula, which in this case it's the O, because we already did the lithium. That was the first part. And O is not more than one atom. That's just one element. And so that means that we would say no to that question. And so then we'd, following the box to the no, for that part, it says we just changed the ending of the nonmetal name to IDE. So we need to know what's the name of O, and then we need to change its ending to IDE. So what element name is O? I feel like y'all probably hopefully know that one. That's a pretty common element. Anybody want to take it? Let's see, Paige, what element is O? Who else is in here? Etsidi, how about you? What element name is the letter O? So it will help you guys if I put the periodic table back up so you can find O. Thank you, it's idiot. Yes, O is oxygen. Okay. So the element name is oxygen for that non-metal, and then we need to change the ending to IDE. So it would be, so after lithium, we would have oxide, and that's it. So instead of oxygen, we drop it off and we change it to IDE. So for Li2O, that's it. It's just lithium oxide. No Roman numeral needed because it's not a transition metal. And no prefixes because it's not covalent. Covalent is where we use the prefixes. Okay. So I don't do, it's not like dilithium oxide. Okay. The two, I don't need the di because this is not covalent. All right. So let's look at this next one. Okay. So now on this one, our formula is NO3. So again, we always start with that same question. So let's see, anybody can take this one. So is there a metal or NH4 in this formula?
No.
There is not, right? So it's pretty obvious, again, there's not an NH4. So really we just need to look for a metal, and there is no metal because if I refer back to my periodic table, N and O are both over here. They are both nonmetals because remember my stair-step line starts here with boron. So they're both on the right side. So they're both nonmetals. So I would say no on this one. That means that I'm going to go this direction into this kind of orangey color. And if I say no, that means it's covalent because they're both nonmetals. So then the next question is, does the first element have a subscript? So my first element is N. Does N have a subscript in this formula? It does not. Thank you, Layla. And it doesn't. So if I kind of go back up here to our first box and look at what happens if we say no, we say no, then we just write the name of the element, that first element from the periodic table. We don't need to add any prefixes if it's just, if there's no subscript on the first one. So that means that we would just have the name for N, which is nitrogen, okay? And then after that, the second one's always the same. So there's not really a question. It's just I need to follow the directions for the second one, meaning that I need to add a prefix to the second element name and then change the ending to IDE. So again, I need to look at my second element. So the second element here is O, which we just had that on the last one. So O is oxygen. But we do need to change the ending to IDE and make it oxide. But then we are going to have to add a prefix. So this is where I would need to look at my little table of prefixes here. Okay, and all this stuff, you can add these in your notes, guys, the Roman numerals and the prefixes. That way you have it written down so that you have it to refer to for your test next week. But if I look, what's the prefix for 3 that I would need to use? Scoot over here so y'all can see it. All right, Layla says tri, that is correct. So 3 is tri, like a tricycle or a triceratops. So if I come back over here to finish, that means that I'm going to have nitrogen, and then I'm gonna have tri, the prefix tri, and then it's oxygen, but we said it changes to oxide, so it's trioxide. So this is the difference between this one and the last one. They both had oxygen, but this one we used a prefix, the other one we didn't, because this one, Li2O, lithium's a metal, which makes it ionic, and we don't need prefixes, okay? Whereas this one, they were both nonmetals, that makes it covalent, which means we do use prefixes. So this is why it's so important that you guys, like going all the way back to our stuff from unit 2 with this periodic table, it's important that you guys know where the metals and the non-metals are, and then also like specifically the transition metals for those Roman numerals, because if you can't figure out where the metals and non-metals are, then following that procedure of figuring out how to do the name correctly or the formula correctly, even if you're going the opposite way, it's going to be a lot more difficult, okay? So, you know, when I tell you guys this class builds all year, like I'm not like just saying that to say that, like it really does. And everything we're doing right now with writing names and formulas, when we come back next semester in January, we're going to build on that, because our next unit has to do with chemical reactions. So we're going to be writing chemical equations and balancing them, and identifying what types of chemical reactions we're seeing happen. And so in order to do all that, we have to know how to write their names and formulas in the equations. And in order to write their names and formulas, we have to know, like, are they metals and non-metals? So is it an ionic or a covalent compound? Is it an acid or a base? That kind of stuff. So again, if you're still struggling with all this, since we're mixing them all together, I would highly recommend that you look on that last page in the module and look at some of those tutorial videos that are in there to help you guys, because they're in there so that you can practice with them on your own time, since, you know, obviously we're not here and we're not able to do it together all the time like normal. All right, so I'm going to go ahead and close out of this because I just wanted to do a little bit of review. And we're going to now move on to talking about our last new lesson for today, which, as I told you earlier, has to do with writing the names and chemical formulas of acids and bases. So acids and bases are kind of like subcategories. Acids are kind of a subcategory of covalents because they don't have metals in them, but they get their own little unique category because even though they're covalent, they kind of act like ionic because we still have to balance charges. So they get their own unique category because of that. Bases, they also get their own unique category because they fit into ionic. We still have to balance out charges, but the anion, the negative ion, is always going to be the same in a base. Just like in an acid, the positive cation is always the same. So because they follow this specific pattern, they get their own little name, their own little category where we have to write their names and formulas, okay? So you have kind of two different, like, in little lessons. One of them, the first one focuses on doing the names. The second one focuses on doing the formulas. And then afterwards you have a practice activity. So you can kind of check to see if you're understanding how to do the names and formulas for them. But as a quick intro, acids and bases are actually really, really common. Everything around us is made of chemicals. You know, the foods you eat are made of chemicals, and your body does chemical reactions, and it, you know, takes the energy, breaks the bonds, and then it uses the energy to, you know, for you to be able to move, to breathe, and all that stuff. And so acids and bases are some specific compounds. We eat a lot of things that are acidic. So things like lemon juice or any kind of citrus fruit, lemons, limes, oranges, grapefruits, all that stuff. Those are all acids. They're all acidic. Vinegar, any kind of vinegar is acidic. There are several other things, sour candies, anything that tastes sour, like sodas, even like regular sodas, lemon lime sodas, all of those are acidic. Tomato juice is acidic. Milk is slightly acidic, not very acidic, but it's slightly acidic. So a lot of the foods that we eat are either slightly acidic or very acidic. Vinegar and lemon juice are probably some of the strongest ones that we actually eat. If they get, you know, beyond that, then they're not safe to eat. Okay. That's when you're going to get to things like hydrochloric acid or sulfuric acid that's in batteries. And so some acids are safe to consume, like in small amounts, but some of them, like, you don't want to consume them at all because they're very, very dangerous when they're concentrated, and they can harm you and kill you. Bases, on the other hand, like, you don't really eat like any bases. The only one base that you eat is baking soda, but you really just use it in very small amounts in like baking and cooking. You don't see people eating like spoonfuls of baking soda. Like, it's not so like somebody pours themselves a bowl of baking soda and they eat it by the spoonful, because A, it tastes really bad, and B, it would be pretty dangerous because bases are all pretty much poisonous. Baking soda is the only one that we can really eat in small amounts and not be poisoned. All the other bases are like cleaning products. So you have like drain cleaner, ammonia, things like Windex, bleach, oven cleaner, even things like shampoos and soaps. Anything that's slippery, like a soap or a shampoo, those are all bases, because that's a property of bases, is that they're typically slippery. They're used to clean things, and they taste bitter when you do taste them. So if you ever like stick your finger in baking soda and like just taste straight up baking soda, it doesn't taste very good. Okay. Acids, on the other hand, they're mostly sour. So anything that tastes sour is going to have an acid in it. And you can eat most of them as long as they're not certain acids. Okay. We actually have a whole unit in the spring, second semester, on acids and bases where we focus more on what I was just talking about, the properties of them, how they behave, what do they do, what are the types of them. For this unit, we're solely just focusing on writing their names and formulas. And then next semester, when we get to the unit for acid bases, we'll focus more specifically on them and their properties, okay? But for today, we're focusing on the names and formulas. So you have a list here, okay? There's four acids here and 3 bases. On the acids, you have hydrochloric acid, which is what's in your stomach that helps you digest food. You have sulfuric acid, which is found in batteries, like car batteries and things like that. You have phosphoric acid, which is one of the acids in soda. There's a second acid in soda, it's carbonic acid. And that's what gives it the carbonation with the bubbles. But phosphoric acid and carbonic acid are both in soda. And then acetic acid, which is what's in vinegar, okay? What do you guys notice that the acid formulas have in common? So look for something, what do they all have in common? Anybody see anything? You can say something in the chat.
They all have
They all have what? Sorry, you cut out.
hydrogen.
Yeah, so they all have hydrogen or an H at the beginning of their formula. So that's when you look at a chemical formula, if that chemical formula starts with H, that's an acid, okay? The only one that's not is water, H2O, okay? Everything else that starts with H is considered an acid, okay? So that's one way that you tell if something is an acid, by looking at its chemical formula. If it starts with hydrogen, that's an acid. For the bases, if I look at them, we have caustic soda, that's sodium hydroxide, that's what's in drain cleaner. Calcium hydroxide is also called pickling lime, because you can use things like calcium hydroxide and other bases to pickle and can and preserve foods. And then magnesium hydroxide is one type of antacid. There are several types of antacids, but all antacids are bases, okay, because they all neutralize the acid in your stomach, so they react with it. So what do you guys notice that the bases have in common, or what's the same about them? So what do we think? What's common to all the chemical formulas of the bases? They all have what in them? Yes. Yeah, okay. Thank you, Ed City, and thank you. They all have OH, right? Which OH is hydroxide. So you notice their names, it's all something hydroxide. It's all like a metal and hydroxide. So it's sodium hydroxide, calcium hydroxide, magnesium hydroxide. So if you look at a chemical name and it says some metal and then hydroxide, you should know, oh, that's a base. Or if you look at a formula like this and it's a metal with OH, you should know, oh, that's a base, okay? So the acids, they'll say acid in the name, or the formula will start with hydrogen. The bases, the name will be a metal and hydroxide, or if you look at the formula, you should be able to identify it's a metal and then it's OH, which is hydroxide. So that's the pattern that they all follow. So that's why we kind of give them their own special categories for names and formulas, even though they follow similar patterns to the ionic compounds, okay, for doing the formulas. For the names, it says bases or compounds that contain the hydroxide ion. So the rules for naming and writing formulas, they're the same as any ionic compound that has a polyatomic ion. So thinking back to our flow chart, we would do the name of the metal. If it has a Roman numeral, we'd add the Roman numeral if we need to, if it's a transition metal. And then we would name the polyatomic ion, which is always going to be hydroxide, okay? So for this one, it says the base BaOH2. Well, I know OH is hydroxide and it's ionic because so it can't have a di. So like the first and the third choice here, they should be out because I'm not going to use prefixes for bases, just like I don't for ionic compounds. So then between the second and the third one, which one do you guys think is the correct one for this one? 2 or 4? So BA, what element is BA? I know it's a metal. Is it barium or is it baride?
Barium.
Yeah, it's just barium. And so since this is named like an ionic compound, if we follow that flow chart for ionics, barium's not a transition metal, so it doesn't need a Roman numeral, and we don't ever change the name of the metal to IDE. It's always, if we change anything to IDE, it's always the second element in the compound. But the second element's a polyatomic ion, so we just write its name, which OH is always hydroxide. So this one's just going to be barium hydroxide. So that's going to be the pattern that the bases follow for names. It's always going to be the name of a metal and then hydroxide. That's it. Okay. So you have another one that you can kind of practice with there on your own. I'm going to go ahead and go on to the acids, because the acids are the more complicated part, because there's two different categories for acids: binary acids and oxy acids. So when you look at the chemical formula, a binary acid is where you will only have two elements. Bi means two, okay, like a bicycle. So binary acids have two elements. One is always hydrogen, because acids always have hydrogen. The other one is going to be a non-metal. That's good. That's your negatively charged one. The oxy acids, they're called oxy acids because they all have oxygen in their formula, not hydrogen. They have hydrogen because they're acids, but they're oxy acids because they have oxygen. So an oxy acid, you're going to see hydrogen because it's an acid. You're going to see oxygen atoms, and then you're going to have another, at least one more element, maybe two. Okay. And so that's kind of how you tell them apart. For binary, they're going to look like these ones here that are in this kind of turquoise color. So notice they all have hydrogen at the beginning, but then they just have one other element. Okay, this one's got fluorine, this one's got iodine, this one's got sulfur. Oxy acids, they still all start with hydrogen. That's how I tell it's an acid. But I know it's an oxy acid because look, all the formulas have oxygen and then another element. Okay, so oxy acids, they all contain polyatomic ions in them. Binary acids are just hydrogen and a nonmetal. That's kind of how the basic for how you tell them apart. Now, as far as doing their names, the reason we have to be able to tell the binaries from the oxy acids is because their names are written differently. If you have a binary acid, okay, you start with the prefix hydro. So if I look at this formula, I see HF. My head should be going, that's hydrogen and a nonmetal, so that's binary. So for a binary acid, the name always starts with the prefix hydro. After I write hydro, then I look at my nonmetal. I look at my negatively charged ion, which is F. That's fluoride, because that's the element fluorine, but it's in the compound, so it's fluoride. And then I need to change the ending of that fluoride to IC. So instead of fluoride, it's fluoric. And I put that behind hydro. So now I have hydrofluoric. That's the first part. And then because it's an acid, I always have to add the word acid. So the complete name for HF would be hydrofluoric acid. The couple things to remember, if you have sulfide or phosphide, anytime you have acids with sulfur or phosphorus, the names are a little tricky. They gain back some letters from the element name. So the sulfide, the IDE drops off, but it gains back this UR from sulfur before you add on the IC. Same thing for phosphide, the IDE drops off, but it gains back the OR from the original element name before you add the IC on. So you have some there that you can practice with. I'm gonna go ahead and go on so we can get finished before we have to go to lunch. Oxy acids, the name of the oxy acid depends on the name of the anion. Okay, notice these are called oxy anions or oxy ions because they all have oxygen with other elements in them, okay? So these are all polyatomic ions, but they're specifically called oxy ions because they all have oxygen in them. For oxy anions, you need to look at, does the name end in ATE or ITE? Because this is what's gonna make the difference. So if I'm looking at a formula, I need to figure out which ion is in the formula so that I can figure out the name of it. If it ends in ATE, then what I do is I change the name, ending of the name to IC and add the word acid. So for example, this one, I have HNO3, so I should know, okay, this is an oxy acid because it's got oxygen and another element with the hydrogen. Then I need to look up what is NO3 because I need to know what its name is. NO3, if you look up on a list, it's nitrate, it ends in ATE. And so if it ends in ATE, I drop off the ATE, I change it to IC, and then I add the word acid. The difference here, there's no hydro. Okay, hydro is only for the binary acids. Same thing here, this one's got SO4. SO4, if I look it up, SO4 is sulfate. Here it is right here. It still ends in ATE. So that means that I would drop off the ATE, but because this is sulfur, okay, it's gonna gain back the UR before I add on the IC and then the word acid. For the other oxyacids, the ones that end in ITE, the only difference is the ending changes to OUS instead of IC. So if I come back up here, this one is HNO2. And if I look up NO2, that is nitrite. It ends in ITE. And since it ends in ITE, that means I drop off the ITE, I change it to OUS, and then add the word acid. And then the sulfur and phosphorus, again, they're going to gain back letters. So there's an example here to show you that one. If I was looking at this one, I have HBrO4. So I know it's an acid because it's got H. I know it's an oxyacid because it's got oxygen and another element with the hydrogen. I need to look up what is the name of BrO4, okay? First off, I should eliminate the second and third answer choices because I know it's not gonna have hydro because it's not binary. So now I need to know, is it bromous or is it perbromic? So I need to know the name of BrO4. So if I come up to my list, BrO4 is right here, it's perbromate. So since it ends in ATE, that would drop off and change to IC. And so this one should be perbromic acid, if I check it. And then you have some more down here that you can practice with as well. For the formulas, formulas of the bases are pretty easy. You do it just like you do, well, in the acids as well. Both of them for acids, bases, you write their formulas just like ionic compounds. The only difference that makes it a little easier is that for bases, the anion's always hydroxide. So it's always OH with a -1 charge. For acids, the cation is always the hydrogen ion. So it's always hydrogen H with a +1. You still have to balance your charges. So the positive and negatives have to equal each other. So you can use the crisscross method and just make sure you check to see if you need to reduce the subscripts. Or you can do like we did in the practice videos before break where we kind of balanced the charges and then counted how many of each we needed to do that. So if we're given a name like this, it says sodium hydroxide and they want us to write the chemical formula. First off, the fact that it has hydroxide in the name, that should be like raising flags in my head. Oh, this is a base. Because anything that's got hydroxide in the name is a base, okay? So that tells me, hydroxide tells me that it's OH -1. And then sodium is the cation, that's a metal. And so sodium is Na, and if I look on the periodic table, sodium's group 1, so it's a +1 charge. On this example, since they are both ones, if I just have one of each, they will cancel out. So I don't need to add any other subscripts because I only need one sodium ion and I need one hydroxide ion, so I just put them together, NaOH, and it's balanced, okay? That won't always be the case. On this next one, they want us to do magnesium hydroxide. So again, I should know it's a base because of the OH, which is going to be OH -1. And then in this one, the metal is magnesium, which has a +2 charge because it's in group 2. So I can do the crisscross. I just have to remember to, erase the 1 that's here because I don't want to write 1s in the subscripts. Or I can just look at the charges and try to figure out math-wise how to balance them. And so I need 2 hydroxides for every 1 magnesium. The one thing to remember is OH is a polyatomic ion. So if you have to do a subscript like on this one, you do have to put the OH in parentheses and the subscript outside first, okay? Acids, you do it the same way. The only difference is you're always gonna have hydrogen +1. The negative ion is what's gonna change. So you have to look at the name. So for example, this one says sulfuric acid. So number 1, it does not have hydro. That tells me that it cannot be binary. No hydro in the name, that means that it has to be an oxyacid, which means it has one of these polyatomic ions in it. How do I tell which one? I look at the ending. If it ends in IC, then I'm looking for the anion that ends in ATE. So sulfuric, IC means ATE, that means I'm looking for sulfate, which is SO4 with a -2 charge. If it ends in in OUS, then I would want the one that ends in ITE. Once I identify the ion and I get its formula in charge, then I do the same thing. I crisscross the charges, if I reduce if I need to, or you can balance by adding the charges together and seeing how many of each ion you need. So for this one, because this is a +1, this is a -2, if I crisscross them, I need 2 hydrogens, so the H gets a 2 subscript. Because I'm bringing a 1 down to the sulfate, remember I don't write 1s, and so I just have SO4 for the sulfate. And so sulfuric acid, this is what the formula would look like. There's another example down here with hydrochloric. So this one is a binary acid, so you can take a look at that one on your own a little bit later. But really quick, I just wanted to show on your check for understanding, there's a couple of different parts. There's a drag and drop part where you're matching names and formulas, okay? I believe it has the names and you have to drag the formula to match it. I've given you the list of the oxyions up here that if you need to refer to them, but you may need to get out a periodic table to refer to as well. But there's more formulas than there are names. So you're not going to use all of these formulas. You'll only use 9 of them because there's only 9 names. And then you have some other practice questions here that you can answer to practice with from stuff from today. Okay. This isn't up there yet, but I will post the live video later if you need to go back and watch anything.